Okay, so last class we went over section 3.1, which was on exponential functions. So we talked about what exponential growth looked like, what exponential decay looked like, how you could graph those if you don't have them memorized. I reminded you of the transformation properties that are consistent from other stuff. We brought up some exponent rules, like anything to the 0 power is 1, stuff like that. And then we looked at two applications, which was the half-life type problems and the compound interest type problems, the PERT and print formulas. Then we went over worksheet 1, where we practiced a lot of that, and we skipped one question type, and then you guys were supposed to have done the back, which was worksheet 2, except skipping the one question type. So if you have some questions from that were not matching up with the solutions on the website, then I will need you to ask. But before we get to our quiz, which will be next class, and you guys know there's no school on Monday, so that'll throw you off your routine a little bit. So on Tuesday, when you come back from your long weekend, we will start off with a 3.1 quiz. And some of the stuff on the quiz are questions like these first 8. Trying to determine if these are exponential growth, exponential decay. Girls, do y'all need something? If y'all need something, then please ask. Or neither. So this is something that students usually feel like they know how to do, but I don't know, a few years ago it was just too many points were being missed on the quiz because of this. So I want you to see if you fall into these traps before we go over these. So for each of these 8, either tell me that you think it's exponential growth. You can just put e.g. Exponential decay. You can just put ed if you want. Or it could be neither of those. So for those 8, please go ahead and commit yourself to one of those 3 answers, and then we'll see if you fall into that common trap or not. Now, I don't know for sure that this is still on the quiz, but it has been on the quiz the last few years, so I just don't want you to miss these easy points. I'm not going to give you more than just a minute or 2 here. Don't put too much thought into them. Just if you really know what you should be doing, this very quick. Also on the agenda, just a quick reminder about ACTM. If you are planning on doing that and you have not paid, I'm turning that money over tomorrow at lunchtime, so you're just about out of time there. But also, if you have any friends that you know want to do it, you might make sure that they have paid. Bless you. Okay, everybody tried all 8 of those? Okay, so to be exponential growth and exponential decay, if we look at it like a to the x, if a is bigger than 1, you get exponential growth. So, scanning ahead, I think try to color coordinate this a little bit. Number 3 is exponential growth, 7 to the x. I think number 6 is, because it's 7 to the x also. The times 2 is just going to make it twice as big, but it is still growing exponentially. What's another one that's exponential growth? Okay, I'd agree. This 1/3 is going to slow it down a bit, but it's still 8 to the x. It's still going to grow exponentially. Now, I think there's some other ones, but those are the easier ones to catch. I think those are your ones you're most likely to have gotten. Just make sure that you know timing by 2, timing by a third doesn't change the fact that it's exponential growth. It speeds it up or slows it down a little bit, but it's still exponential growth. Okay, if it is exponential decay, then A is going to be between 0 and 1. The reason why we say between 0 and 1 is because if it's negative, then that's a reflection. That doesn't have to do with what type of exponential it is. So I'm looking at these, and none of them, oh, there's one. Question number 1. 1/6 to the x power, exponential decay. I would say number 2 and number 4 are going to be the most missed ones. And part of it is because of exponent rules. So you're going to be tempted to say that this is exponential decay because this is 1/5, but it's not 1/5 to the x power, it's 1/5 to the negative x. So with exponents, if you want to make the exponent positive, you can take the reciprocal of what's underneath it. So number 2 is actually exponential growth. Likewise, number 4, to make this a positive exponent, you have to take the reciprocal of what it's going to. So it's tempting to say number 4 is exponential growth, but it's actually exponential decay. You just have to rewrite it. That rule of bigger than 1 or between 0 and 1 only works if the exponent is x. And then these two, why is 5 and 8, why are these not exponential functions? I don't know if you call it to the 4th power parabola. Like it kind of looks
fixed number, but they're not continually growing.
Because A isn't less or more than 1.
I'm thinking of exponents. To be exponential, the variable has to be in the exponent. If the variable's not in the exponent, it's not an exponential. Okay, so obviously I'd love if you all got all 8 of those correct, but again, just from past what I've seen, students don't, especially question 2 and 4, students like to oversimplify that rule, and that rule of bigger than 1 or 0 to 1 only works if your exponent is x. So if you miss those 2, that's great, or that's fine, but make sure that you mark those 2 and put in some notes so that if it is on the quiz, you won't miss those points. Okay, anything y'all want to ask about that before we go on? Did anybody get all 8 of them right? Okay, good. I'm glad we spent some time on it then. Okay, then also last class, section 3.1, worksheet 1 and 2, there was one question we skipped on the front and one question I let you skip on the back because we were just kind of pressed for time. So these questions take, I could have explained it, but it would have been a little bit rushed and wouldn't have been as helpful. So we've got 4 of these we're going to look at. And then one of the things I will ask you to do once we're done with this worksheet is go back and do those 2 that you skipped from worksheet 1 and 2. Now, when I work these question types, what I have found that works best for most students is there is 3 things that often come up in these questions. And if you know these 3 things and are actively looking for them, it makes these questions a lot easier. So one of them, the numbering doesn't really matter, but if you have a number and the exponent is headed towards 0, what do you think all of that is headed towards? 1, because anything to the 0 power is 1. So when we plug this stuff in a minute, anytime we have a number but its exponent is going towards 0, we'll just change all of that to be 1. What about if you have a number and the exponent just keeps getting bigger? What's going to happen to this? It's just going to keep getting bigger. So that goes to infinity too. And then the last one, again, not every question needs all 3 of these, but these are the 3 that come up, at least one of these in every question. If you have a number and the exponent goes to negative infinity, well, let's write what this means. I still think it helps to memorize it, but remember a negative exponent in the numerator is like a positive exponent in the denominator. From rule number 2 here, we know that this just keeps getting bigger. And what happens in a fraction if your numerator is stuck still but your denominator keeps getting bigger? Smaller, like negatives?
No, she's
Closer to 0.
It gets closer to 0. So if you have a hard time visualizing that, you can just throw in a few into your calculator. You can see quickly as the denominator gets bigger, the whole fraction gets closer to 0. So if you have a number and its exponent heads to negative infinity, that whole thing just goes to 0. So these are, to me, the key to these questions. If you have those 3 memorized, these are a lot easier. Okay, so let's look at question 9. So one time we want to know what y value is this approaching as x gets really small and as x gets really big without a calculator. Of course, if we had a calculator, we could just graph it and kind of look at the graph. But we're trying to predict what's happening here. So one time you need to take your equation and plug in negative infinity for x. And you need to try to think about what's happening here. And there's a lot of stuff going on, so you gotta go one step at a time. This right here, e to the negative infinity, what is all that gonna go to? One more time. 0. So if you have this third one memorized, you're not having to put too much thought into that. You can just make that. E is just a number. And so then my denominator goes to 2, which means my whole fraction goes to 7/2. So if I was to graph that, the left side of the graph gets closer and closer to y values of 3.5. Okay, and then one time you need to plug in positive infinity, and you've got to try to break this into as many pieces as you can and kind of step this out. What do you think e to the infinity is going to go to? Okay, and that's rule number 2. A number to the infinity, a number whose exponent is just getting bigger, is just going to keep getting bigger. If we add 2 to infinity, that's still going to go to infinity, just 2 faster, but in the grand scheme of things, that doesn't really matter. And then in my fraction, if my numerator is stuck at 7, but my denominator keeps getting bigger, what is this whole thing going to go to? 0. Same idea as this guy.
Wait, what? What'd you say?
7 divided by a number that keeps getting bigger gets closer to 0. Just like a number 1 divided by a number that keeps getting bigger gets closer to 0. So same thing I did here. 7's just a bigger number. In fact, you can't even make the denominator very big before your calculator starts running out of decimal spaces. If your numerator is stuck still, but your denominator just keeps getting bigger forever, your whole fraction gets closer to 0. So the idea of this is important. Okay, so let's try that again. Different equation, probably going to play out a little bit differently, but it's going to be kind of the same steps. So question 10, let's plug in negative infinity the first time. And then one step at a time, we have to try to figure out what's going on. So I would say, let me try to figure out what's going on with this exponent. Well, first off, this is a positive divided by a negative. Positive divided by a negative is negative. And 2 divided by a number that goes to infinity would go to what? 0. Whether it's 1 over infinity, 7 over infinity, or 2 over infinity, it goes to 0. Well, 0 is the only number that doesn't care if it's positive or negative. So I guess I can change that. Doesn't matter. Okay, and then e to the 0, what does this head to? 1. That's one of these. Which means your denominator is going to 2, which means your whole fraction is going to negative 5/2. So the far left of that graph approaches a y value of negative 2.5. Okay, let me do this one more part for you, and then I'll have you try the next two as guided practice. Give you a chance to try it and see if you're doing it correctly. Okay, I'm just going to erase this. I'm out of space. Okay, so the next time I'm plugging in positive infinity, and I can't keep up with all of this at once. I've got to do a little piece at a time. So e to the infinity, what does that go to?
Or what about your two?
My 2?
Two over infinity?
Oh, yeah. 2 over infinity, thank you. Okay, what does 2 over infinity go to? 0. What does e to the 0 go to? Which means my denominator is going to 2, and my whole fraction is going to negative 5/2. What I like about these first two examples is this one you can see that they can head to different numbers, but they don't have to. It depends on the equation. You could be approaching the same thing on the left and right, but you might be approaching different numbers. So you can't just assume it's one or the other. Okay, so take a minute and try question 11. Plug in negative infinity and see if you can keep up with what's going on with all of that fraction. And then also try positive infinity. We'll check it, and then we'll do one more guided practice with it on 12. And then, again, you guys still have 2 of these from last class's worksheet that you do need to go back and finish. So there's a little bit more practice. But I had one more handout I was wanting to give you guys today. I just forgot to put it out.
Oh wait, no, yeah, they have to be negative. What do you have you get to?
Yeah, negative 2.
Oh, sorry.
Okay, I think the answer's here. It's a lot for me to do in my head, but I think it's going to be 0 and negative 2. Y'all got some of those?
How'd you get?
I got that opposite.
How'd you get 0 for the top one?
Well, I'm going to work it out. I just wanted to start with that. That way, if you got both those and most people agreed, you could just move on. You didn't have to listen. But Okay, so first off, for the top one, plug in negative infinity. A negative times a negative is positive. 5 times infinity would be infinity. It's not really infinity, but a number that's going to infinity. Then what does e to the infinity go to? And if your fraction is stuck at 6 over and your denominator keeps getting bigger, then all of this goes to 0. So that one looks okay. These signs make a difference. If you're not keeping up with whether it's positive or negative, it can work out different than you expect. Okay, and then really the other part's just one different step in here. So if you plugged in positive infinity, a negative times a positive would be negative. 5 times a number that goes to infinity would go to infinity. And this is one that I suggested that you memorize. If you have a number and the exponent goes to negative infinity, all of this goes to 0. So your whole denominator goes to negative 3. So your whole fraction goes to negative 2. So highlight what it is, what mistakes you may have had if you did have any. Put a little thought into those for a moment and then try one more time and see if you can correct those with number 12. Okay, I think both these go to the same number. Are you getting 1, I think? 1 both directions?
Yeah.
Okay, if you're not getting 1, then let's see what's different. So I plugged in negative infinity already for us. Again, try not to do too much at once. You really need to do the smallest little piece that you can at a time. So right here, a negative divided by a negative is positive, and 4 divided by a number that keeps getting bigger goes to 0. Then this matches up with one of the 3 I suggest you memorize. And so your denominator goes to 4, so your fraction goes to 1. Down here, if you plug in positive infinity instead, again, sometimes that makes a difference, sometimes it doesn't. Now a negative divided by a positive is negative. 4 divided by infinity would be 0. But 0 is the only number that's the same whether he's positive or negative. It doesn't make a difference. So that still went to 1, which means that still goes to 4, which means your fraction still goes to 1. So unfortunately, our textbook doesn't like give a lot of good practice questions on those. But I really feel like the key to these is every one of these questions uses at least one of these, if not multiple of those. So if you know those three and you're actively looking for them, that makes those questions quite a bit easier. But you got 2 more of those to practice. Okay, so first thing I'd like you guys to do, well, you should stick with 84 for a minute until like you feel like you've absorbed that information. But 83 from last class, we skipped 1 question on the front like this and 1 question on the back like this. I'd like you to go back and finish those so that that is complete. I will ask for that before our quiz on Tuesday. And actually, I'll just go ahead and open up the assignments I expect you to have in Google Classroom here in just a minute. But you guys know you can turn them in before the quiz as well. So finish up 83 with those last 2. Make sure that your answers match up with what the website says. If they're not, then please ask. The other handout that I had for you guys that I passed out by hand is actually the test review. Some of that will be relevant before spring break. Some of it won't be relevant till after spring break. But page 1, which is questions 1, 2, and 3, is all stuff from section 3.1. So I'd like you to go ahead and do those 3, because then that serves 2 purposes. You're getting a touch more practice before the quiz, but you will also have 1 page of your test review done, which will mean you'll have 1 less page to do in the future. But if I was you, I would look over the notes, worksheet 1 and 2, and the extra practice. Those are the 3 things that I would look over. If you guys have any questions, obviously there's a lot of class time that you guys can ask. But we will quiz on this so we can move into logarithms next Tuesday. So, any questions on any of those assignments, please just let me know while you guys are here. And of course, I always recommend that you guys jot down about the quiz so you don't forget about it. But again, especially with the long 3-day weekend, that's probably not going to be on the top of your brain about stuff that you got to take care of. So please make some kind of note somewhere so you don't get caught off guard. Before I let you guys leave y'all alone for a few minutes, did y'all please tell me that you understand this meme today? I know it's not a funny one, but square root of a squared plus b squared is not a plus b. That's not how that works. You're not supposed to. You were supposed to know that. Yeah, if you try to do it, the earth explodes. That's the joke part of it, but you should not take square roots that way. I saw definitely a handful of those on our 1.9 quiz, so I can't pass those back yet because we've still got 8 people to make it up, but when you get yours back, there was a question, some of you guys went 1 step too far. That was not true like that. Okay, please let me know which